All right, line T1, we're in learning task number 1, which is going to be dealing with our 8 exits and our emergency lighting systems. What we're going to talk about are going to be systems that are usually seen mostly in public buildings. Occasionally, private buildings will go and have these as well, but usually these are going to be in places that are public. Businesses that are going to go and have the public into them, or public institutional buildings, hospitals, schools. If we were in at the TTC Center right now, I'd walk out into the hallway and we'd all take a look at it and go, ooh, ah. Because any place that we have got the public in, we've got people that are going to be unfamiliar with how the building layout necessarily might be. You get people in there for the very first time. And as a result, if there's a power failure in that building, particularly at night, we have got a major issue in that we need to be able to go and direct people out to where our actual exits themselves are going to go and be. So what we are going to go and have is we're going to have a two-part system. We're going to go and have exit lights, which are going to be those lights that literally say exit. I'll just draw them as red X's, that are going to go and be on the building itself. They're going to identify any exits that we are going to have, or paths to exits. You'll sometimes see them on second floors, on a stairway, where that stairway is going to be needed for somebody to go and access down to the actual exit. So it identifies our exit systems. And then what we're also going to go and have is we are going to go and have a number of, and I'll just draw this in here as kind of a main corridor or something like that. We'll stick a doorway through to there. What you're also going to go and have is you're going to have emergency lighting. And emergency lighting helps people get to the exits, helps them find their way and get to the exits. And what it's going to be is it's going to be little lights, we'll draw them in here as little V's, that are going to go and keep public accessible areas lit so that people can find their way to those exits. Two separate systems, but designed to work in conjunction with each other. Both of them are termed as being life safety systems, which means that we are going to be very careful about how we wire these things up. We don't share these circuits with other random stuff. We don't want these ones tripping out. We don't want to have problems, caused by just the regular day-to-day life that we have inside of a building that are somehow going to get transferred onto exit and emergency lighting. You'll see them, generally speaking, in hallways, not so much inside of personal spaces like offices and stuff like that. Most of you could, find your way out of your bedroom with your eyes closed. Most people that work in an office are going to be the same thing. They can find their way out of their personal office with their eyes closed, but the rest of the hallways could be a little bit more difficult. Same with public areas like washrooms. You don't have natural light in most washrooms because you don't want a window. So you're also going to go and have, these exit lights inside of those areas. What you will see is a bunch of different configurations, but they're all going to go and be designed to be fail-safe configurations. Which means that if I've got something like a washroom, I'll just draw one in right over here, that's going to be a completely closed-off area. What you'll find is inside of those, you're actually going to go and have two. You're going to have double heads that are going to be off of these exit lights so that if any one of them would fail, at least that whole area is not going to be dark. All of them are going to go and have the same sort of things inside of them. First of all, they are going to be battery-powered. We are going to go and have exit lights that are on all the time, but when the power fails, the exit lights need to be taken over by battery. The emergency lighting are going to be off most of the time, but they're going to come on whenever the regular lighting in an area were to go and fail. So if this were my regular lighting inside of these hallways, I'm going to go and monitor that with this circuit over here that is my emergency lighting, and if for whatever reason the power to that area were to go and shut off, not the light switch, but the power to it. Because it could be that the building's empty and somebody just turned off the light switch because they don't want the hall light running. But if the power that supplies that circuit goes off, then these emergency lights would kick on. They're going to be running off a battery. Obviously, that battery is going to need to be maintained, so we're going to need to have some sort of a charging system inside of there. We also need to have some way to test it so we can verify that these systems are not screwed. And we're going to have some sort of bulbs inside of them, exit lights and for our emergency lights. Usually they're going to be plugged into systems. They're not always plugged into systems. At times they can be wired in, but it's very, very common to see these things that they're going to go to a little receptacle up top over there. And then you just kind of plug them. You're going to have a receptacle mounted up high on the wall, 2.5 meters minimum. That is going to go and plug into these things. As soon as power is lost to that receptacle, this emergency light would automatically kick back on. For construction of these things, they're usually going to be LED at this point. They used to go and have a lot of incandescents that were utilized inside of these, but that has all disappeared at this point because incandescents, convert about 90% of their energy gets converted to useless heat, and only about 10% ever makes it out as actual light. So we do not see these things widely used anymore. Old installations will still have them, but new installations are mostly going to be LED. Inside of the actual emergency, supply case that we have here, we're going to have batteries, oftentimes made up of smaller cells that are going to be series connected together. They're usually going to come from the manufacturer disconnected, because otherwise these lights would be on the whole time, and we discharge and flatten out those batteries. So we will, once we've applied power to this, we will have to go and connect the battery in as well. We are going to go and have a battery charging set on the circuit board over here. There's going to be a circuit board that's going to have a transformer. It's going to kick us down to a lower value of voltage. That lower value of voltage basically gets fed out to these batteries at all times. And then if the power were to go and fail, we are then going to take the power from the batteries and we are going to flow them up to the lights themselves. Some cases, the lamps are going to be mounted directly on this. Other times, we are going to go and have blind units that are not going to have any lamps on them. So just remove those lamps over there. And when we do that, what we'll do is we'll go and wire from here. We'll take DC wiring out to remote mounted lights that are going to be in other locations inside of our building. It's another common way for these things to happen. We do have, to make sure that this stuff is going to be mounted up high, we want to keep it out of the way of, just accidents, vandalism, anything like that. It's designed to be a fail-safe emergency type of system. There should be something on the side that is going to go and indicate when we have got stuff turned on, that it's charging. So we want to verify that there's power to that unit, so the battery is going to be charging. We are also going to go and have another light that often is going to tell us when it's turned on, because in some cases we can have this dead-headed unit like this one that's blind with our lights mounted remotely. And then we also have got a test switch that we can use to go and just fake a power disconnection. That's all it does, is it disconnects this power that's incoming over here, fakes a power failure, and you can see if your lamps themselves are going to go and be working. Two types of protection that are sometimes included inside of them will be brownout protection. These are going to go and turn on sometimes when it's not a complete power failure, but just when the power failure is too low, that we might not see the actual hall lights lit anymore. If you got things like fluorescents that are going to go and lose their strike across the tube, then you would want these emergency lights to come on. And some of them are actually programmable. Well, not really programmable, but you adjust a little dial that selects, what voltage you want these things to trigger at. We've got another one that's going to be a low voltage battery disconnect. If we run this for a long time, we've got a power outage that lasts a couple of days or something like that, what we'll have is we're going to go and continue to go and draw from here. And so there gets to this point where all of a sudden these batteries are going to get too low in their voltage. Batteries can get damaged if we deep discharge them. So we can go and have systems that will disconnect these. The batteries that are going to be inside of here will all have to be what we refer to as secondary cells. Secondary cells are just going to be rechargeable types of battery. Common ones are going to be lead acid, NiCad, and lithium ion. NiCad's probably the least common at this point. Lead acid is still very common. Sealed lead acid types of batteries that we will have. Lithium ion is also gaining some steam inside of like the small CR2023, not 2023. I'm blanking on the name there, but the same ones that we have inside of our battery packs inside of our drills right now. It's a tubular battery shape, and it's very common out there. So common right now that I can't remember the name. This is going to bug me, and I'll remember it partway through this later on. Oh well. For the lamps, we do have to go and have a minimum on time specified in our code. We're going to go through a pile of code yet in this section, so we'll leave those rules for now, but we'll identify them later on. But they have to go and burn for a minimum of 30 minutes. That's going to be for a standard place, an office or something like that, where power's out, everybody go home. We're going to have other areas that are going to have to go from, half hour up to an hour or even up to 2 hours, particularly institutional ones, hospitals and stuff like that, where it might take a couple of hours to get everything organized and people ready to go, etc. That's all going to be determined by the National Building Code, how long they need to be on specifically for. We just have got a minimum on time that is always going to be based upon that half hour. So the number of lamps that you connect to these, particularly when you start having remote lamps, we'll start daisy chaining out a bunch of lamps over here. If you start connecting out too many lamps, you run into this issue where all of a sudden you can go and draw down that battery too fast. You're not going to be able to hit that minimum on time. So always make sure that you're following the manufacturer specs of these things. Just because it works when you flip the switch doesn't mean it's going to still have battery capacity a half hour from that. Make sure you are only using listed and approved components. You're not allowed to just take any old 6 or 12 volt light connected onto one of these systems, because it has to be something that the manufacturer has recognized as part of their assemblies. Yeah, they talk about that, some of them used to be the quartz ones. Quartz halogen is a really intense light, but it is also a very high power drain. Those ones have mostly all been supplanted once again by the LEDs. Exit signs, a little bit different. That's, these ones over here. Exit signs themselves are going to go and be mounted either on the ceiling or on the wall. They are going to be red or green. They're sometimes going to go and have knockouts towards either end that are going to be these arrows so that you can use them to direct people towards the exits. So in some cases, we'll have these things, blanked over. If I can blank that one. Yeah, I can blank that one. And then if this thing was pointing down a hall, what you would have to do is you'd have to remove that knockout so that it's going to go and direct people towards where that exit itself actually has to be. If you do not need to go and have the arrows on there, don't take them out. Leave them inside. It does not actually meet code if you remove them, because you're directing people away from the exit at that point. Exit signs are usually going to go and have dual types of lamps if it's an old one. So an old type of exit sign would go and have a bulb that would be fed in. I'm just going to jump ahead to this one over here. It would have a bulb that would be fed in off of a 120 volts, just a small low wattage bulb, and usually it would actually be two bulbs, just in case one bulb goes out, so that you would actually be able to tell that it would be out. So this, let me draw that, normally would be two bulbs. And you've seen that probably on these fixtures, where half the picture is a bit dim. That tells you that one of those two bulbs is going to be out. It's 120 volts that we would have on those. Then what we're also going to have coming in is we're going to have another one that's going to be a 12 volt DC. Usually that one was a single bulb that would be coming into that one. So that if my AC power were to go and fail, that single DC bulb would be able to go and turn on. There's a new type as well that is going to be a electroluminescent style. These ones have not taken off absolutely everywhere yet, but they are allowable under Canadian Electrical Code. And I'm just going to bring up a special rule to do with them, 46, and we're going to go all the way to the end of 46 to the 46400s. (46.400) deals with exit signs, and just only exit signs. But it says under subrule 1, where exit signs are connected to an electrical circuit, the circuit shall be used for no other purpose. It has to be exit lights alone. Then subrule 1 says, notwithstanding the fact that they should be on their own circuit, we are allowed to connect them to the circuit that supplies the emergency light. So the emergency light and the exit light can be together on the same circuit in the area where the exit lights are installed. And then exit signs referred to in subrule 1 and 2 shall be illuminated by an emergency power supply, where emergency lighting is required by the National Building Code of Canada. And then it says under number 4 over here, the circuitry serving luminaires used to illuminate exit signs that are not connected to an electrical circuit. I want you to highlight just that word. That exit signs that are not connected to an electrical circuit. These are glow in the dark, or photoluminescent types. So the circuitry that serves luminaires, in other words, the wiring to a light that is going to go and be lighting up the photoluminescent sign, shall comply with subrules 1 to 3. What they're talking about specifically inside of here is that if I have got a glow-in-the-dark type of exit sign, I'm going to probably be, well, first of all, it's in an institutional setting, so we're just going to go with the assumption that we've got a troffer inside of the T-bar ceiling. The light that is closest to this, that light is going to be always charging it up through, the photons that are going to be bombarding that surface. Because that light is necessary for this exit sign to operate, that specific light, even though it's a hallway light, it can be connected onto our exit lighting circuits. The old style where we had dual type like this has now been supplanted by, in most cases, it's an LED style where we only need to go and bring in a single set of wiring. And what's happening inside of those new ones is that we are going to go and take in our AC. We are then going to go and convert it to DC. You know all about that. Oh, I'm writing that backwards today again. But DC, which is going to go and be done through diodes. So we're going to convert this thing into the DC. Once we get this thing into the DC, then we are going to go and tap off that DC, and we're going to run that in two directions. One direction is going to go up to a battery. The other one is going to go to the actual lights itself. So we run that in two directions, that DC. If at that point the light itself were to go and fail, so the AC were to go and fail, so we have no more AC, at that point, the battery would just continue, it would reverse its flow, where we continue to go and supply power out to the light itself. We don't have any transfer switches inside of here. It's a relatively straightforward and easy system to go and maintain. None of this fancy wiring that you have to go and do with these. Every single light gets its own small little battery pack that's going to be inside of it. Okay, we are going to go and leave this one off over here at this point because we've described the installations. What we're going to do next is we're going to have a separate one that's going to be all of the code, where we're just going to go through all of those rules. So stay tuned. We're going to have a part B to this wonderful little video.